Hi there, let us build a supervisor multi-agent architecture. If you like this video, please consider subscribing and following. A supervisor agent coordinates the work between multiple specialized worker agents, deciding who should handle each part of the task. Now let's say we have a supervisor agent with 3 worker agents, a researcher, an analyst, and a writer. The supervisor decides at every step which worker to call next and whether the task is finished or not. Workers report back to the supervisor, which integrates the output and decides the next move. Now let's look at the Python code to build this multi-agent architecture. We'll be using LangGraph to build this. Let's start by defining the role of each worker agent, the researcher, the analyst, and the writer. Each role is just a system prompt that tells the large language model what to specialize in. Next, let's define the state, an object that holds all the information exchanged between the supervisor and the worker. The state has got 3 variables. The message, which carries every message exchanged between the supervisor and the worker. The variable next, which holds the name of the next worker to call or finish when the work is complete. And iterations, which keep track of how many rounds of communications have happened between the supervisor and the worker. Now let's create the supervisor agent. Now since we are using LangGraph, each agent is represented as a node. We first create a decision prompt that lists all the worker agents and ask the supervisor to pick the next worker or finish if it's done. The supervisor's response has to be either the next worker's name or finish. Now let's connect the supervisor prompt to a large language model. I'm using openai chat completion create function with the GPT-4o mini model. We pass in the decision prompt which we have just created. The output is a dictionary that contains the next action to take. Now let's create the worker agents. Just like the supervisor, each worker is a node in LangGraph and each worker is connected to the GPT-4o mini model. The list of messages passed to the large language model has got 2 parts. The first is the system message, which is the role of the worker agent. And second is the user message, which comes from the supervisor. All the messages exchanged between the supervisor and the worker happens through the state object. The output of the worker is a dictionary containing the worker's new message appended to all the previous messages. Now that we have defined our agents, let's build the supervisor and multi-worker architecture. In LangGraph, this is also called as a graph. We create a graph object using the stateGraph function and pass in our state. We add the supervisor agent to the graph using add node. And then we add all the 3 worker nodes to the graph in the same way. Now we need to connect all the nodes, which in LangGraph is also called as routing. Let's create a route that will either go to a worker agent or to the end node based on the information available in the state. Now let's add the route as a conditional edge from the supervisor to all the 3 workers as well as to the end node. Let's also add a route from each worker back to the supervisor so that after every worker finishes, the control returns to the supervisor for the next decision. We also set an entry point of the graph as the supervisor node, and this is where every run begins. And finally, we compile the graph and invoke it to run a multi-agent system. Now let us execute this multi-agent architecture. Now let's say we have a user query such as should a 50-person startup adopt a vector database or stick to Postgres plus PG vector. First, the supervisor is going to make a routing decision and pass the task to the researcher. The researcher will gather all the facts and return its finding back to the supervisor. Next, the supervisor makes a routing decision to pass the research to the analyst. The analyst studies the research and replies back to the supervisor. The supervisor then routes the analysis to the writer. The writer summarizes the work done by the researcher and the analyst and sends the polished results back to the supervisor. The supervisor delivers the final output and the graph ends. So congratulations, you just built a supervisor multi-agent architecture. If you want to try this out in a very interactive way, you can go to my platform datajarvis.ai and select the app called as Agent Builder, where you can try this out. Thank you for watching.